So after understanding something about how these devices work, how something can be printed, now we are ready to understand more on output primitives. Basically, now we are trying to understand if we want to plot a point or plot a line, how these things can be done. So basically, here we will learn what a point is, how this point can be drawn, and what are lines and how these lines can be drawn. Definitely, we will also learn about circles and other primitives, but for now, we will learn something about point first, because whenever we try to print something, we will have to understand what is a point and how it can be printed. One thing that we all should agree is that our computer screen will appear something like this, where it will have scan lines as well as the columns. Okay, so let us call these scan lines to be y and these columns to be x. Then a point anywhere, a point, suppose here, will be a position which can be defined in terms of x and y. Okay, so this position is x comma y. So whenever we think about plotting a point in a raster graphics system, we understand in raster graphics what happens. We scan line by line and keep on plotting. What do we scan? We scan a frame buffer. So whatever we are trying to plot on the screen, we keep that information in the frame buffer. Frame buffer, you can understand the frame buffer as a matrix, x columns and y rows. And then here we can keep the values. Suppose we want to plot it, so I will keep 1 at the position xy. If I have kept 1 at the position xy, so in the next refresh cycle, when the frame buffer is being scanned, and when it encounters a 1 here at the position xy, then according to the output device, that particular position xy on the output panel, it will be displayed. Suppose it is a CRT, cathode ray tube. What will happen? There will be an electron beam which will be directed towards this position to glow. Okay. If at all it is another kind of device, suppose it is a plasma panel or other place, in plasma panel what will happen? The two conductors will be slided to this position xy, where when it is slided to here, according to the frame buffer, this particular position when it arrives, since it is 1, what happens? The gases will be ignited, energy will be given to them, and it will generate a plasma, glowing plasma, okay, which will be visible. So what would be the design of the output device? According to that, this particular position will be visible. So this is a point. Now if you have to think about a line, what will happen? when you have to think about a line, in that case you have to think about 2 points. In your plane, suppose this is a point and this is, let me keep it nearer, this is another point. So in between these points there should be a line, right? If at all it is not a raster scan, it is a random scan, then this will be given and a straight line can be drawn like this. Okay. However, you have to understand that in raster scan you have to go on line by line scanning. You have to go on scanning line by line, and whatever pixels are coming by, they should be plotted. So here in this scan, what I believe, those pixels like this one, this one, this one, and this one, also this one, also this one, and this one, this one, this one also, and then this one. Okay, this may also be. Okay, so in this way this was plotted, and then although it doesn't seem to you like a straight line, but still it is a line. I believe this will also be, let it be. So this is a line. Now at some places it is not a smooth line. At some places some staircase events, staircase like these things are visible. Okay, isn't it? So these stair step appearance, let me name it stair step appearance. This is visible in raster graphics line drawing algorithms. Okay, you can also call them as jaggies. Okay, so this is the thing that you have to understand, that the line will be represented by two endpoints. One endpoint will be x1, y1, and another endpoint will be x2, y2, right? It will be this x1, y1 means x1 is the column and y1 is the scan line, right? Similarly, this position also, this is x2 and this is y2, right? So always you will have two endpoints for a line. One is x1, y1, another is x2, y2. So these things you will have to consider while printing a point or a line. Now, if you understand some more things, let me tell you about a line that we have studied in mathematics about a line. We call it Cartesian slope-intercept equation. Let me write it here. Cartesian slope-intercept equation. Okay, what is this equation? You would have seen this equation many a times. The equation looks like y is equal to mx plus b, m dot x plus b. Okay, so This is the equation of line, which means if a line is represented by y is equal to mx plus b, then given the value of x, you can easily compute, given the value of x, m and b, you can compute y value. Okay, suppose this is your line. Okay, this line is y is equal to mx plus b. Whatever the starting position was x1, y1 and x2, y2. Then if you are given any value of x, suppose this is something x3, and you are asked to find out what will be the value of y. So in short, you have to find this position, right? This position, and corresponding y will be this value. Let me call it y3. So for this, you should know a few things. What you should know? You should know that what is the slope. M is the slope of the line. What is the slope of the line? You already know the value of x3. Okay, and you should also know the b. B is the y-intercept. Okay, means, okay, let me not write it like that. It is something different that you will understand like this. Okay, b is y-intercept. Anyway, you can find easily the value of m and b given the values of x1, x1, y1 and x2, y2. If you are having this x1, y1 and x2, y2, you can easily find m. How? For finding m, it is a formula. You will write y2 minus y1 upon x2 minus x1. Okay? Very simple it is. This is x2 and this is x1. So x2 minus x1 will give you this value, and y1 minus y2 will give you this value. Okay. Having this information, you understand that this is perpendicular and this is base. Given this information, you can easily find, usually it is angle, you can understand, but let it be. Let me just okay, let me tell you if I am telling. So given the perpendicular and base, what happens? This is the perpendicular and this is the base. Then you can easily find this angle. Okay, so sometimes although it is not required here, but if I am saying, I am telling you that sometimes you will see tan theta is equal to the slope. Okay, this is tan theta is equal to this slope. This slope, whatever the value is coming after division, certain value will come, maybe in fractions. So that value will be equal to tan theta. And if you really want to find the angle at which it is inclined, so it will be theta is equal to tan inverse this particular value. Right? That is a different thing. We are not going in that detail. Okay. This is this m is enough for us. We are finding this m. This is the formula using which we are going to find this m. So after that m, we have also to find the b. Now what do you think what the b will be? From this equation, what b can be? Y is on this side. So suppose for this point we are thinking about. So for this point, x is known, y is known, and m is already known. So using this information, you can write it as b is equal to y1 and this thing will come on the left hand side. It will be in subtraction, y1 minus m into x1. Why are we taking x1 and y1? Because whenever we are asked to draw a line between two endpoints x1 and x1 y1 and x2 y2, these 2 points will be known to us. So using this first point and the slope, we can derive the value of b. So now we have the value of m as well as the value of b, having known the 2 endpoints x1 y1 and x2 y2. Now for drawing a line, what we need actually are the points in between these 2 endpoints. Okay, so for that purpose we will need to find something. Like if we are moving in this direction, this was x1 y1, now we have moved x1 plus 1, then what will be the value of y? x1 plus 2, what will be the value of y? What will be the y-intercept? If we have moved 3 units in x direction, what will be the new y-intercept? Okay, so this is how we have to, this is what we have to calculate. Now how will we calculate that? Very simply, suppose you have to calculate delta y given delta x. What you have to do? Very simple, it is m into delta x. Okay. Similarly, if you have to obtain x interval, suppose you have to find out delta x, then what it will be? It will be delta y upon m, isn't it? This y2 minus y1 can be considered as delta y, and this can be considered, okay, means this should not be considered. Actually, this 1 unit difference, the unit difference is being considered as delta. Okay, so the unit difference in x direction is delta x, unit difference in y direction is delta y, but m is always helpful. Okay, here delta y you can assume as y, whatever location it was, yk plus 1 minus yk. This can be xk plus 1 minus xk will be delta x. Such things in this way you can consider delta x and delta y. So basically what we are trying to understand here is, till now we have known that given the point x1 y1 and x2 y2, we can find 2 values, value of m and b. Now we can use these values to find the position of the intercepts. Now the question is, either we should go on moving x, means moving x 1 unit each time and finding out the delta y, or we should go in this direction, moving y 1 intercept and finding out the x value. Okay, these may depend totally. But one thing we have learnt here, that there will be 2, if at all we are aware of the 2 points x1 y1 and x2 y2, then we can use this formula, use this method somehow to find out the intermediate points. And if we shade all these points, then a line is clearly visible. Okay? Okay. So the first algorithm for this will be Dda algorithm. Okay, one is Dda algorithm. Okay, DDA stands for Digital Differential Analyzer. Let me write it. It is Digital Differential Analyzer. So what happens here? Here it will understand there is a raster scan system. So line by line it is going on. Line by line it will scan the buffer and print. So accordingly what we have to do is we have to update the frame buffer, right? Given the two endpoints, we will find out the intermediate points and these points will be set to desired value in the frame buffer. Okay. So here Dda algorithm will help us in finding the intercepts in between the two endpoints to make a good looking line. Okay. So now suppose we are already aware of these functions about delta x, delta y we can calculate, m we can calculate. So now we have to understand that slope can be positive or negative. Okay, the slope can be positive or negative. Slope can be positive means m value is greater than means m value is positive, control Z. M value is positive. So if this is an example of positive slope where from x1 y1 to reach x2 y2 both the values are increasing, right? This is a positive slope. And in a negative slope what will happen? It will come down. Okay, from x1 y1 it will come down towards x2 y2. Let us consider first of all the positive slope. We will see both of these two positive slope. If at all the slope is positive, then we will have two cases. We will consider two cases. Case 1, if the slope is less than or equal to 1. If the slope is less than or equal to 1. In that case what we are going to do? We will consider x as the unit interval. Okay, we will take delta x as 1. Okay, and considering this, we will compute each successive y. We will compute successive y, I should say. How we will compute? Not that formula. We will use yk plus 1 is equal to yk plus m. Why m? Because how we compute delta y? Delta y was m into delta x. So delta x is already 1. So the only thing to be added is m. Okay. So this is what we are getting here, right? So actually in y, whatever the y earlier value was, new intercept is to be added, right? Since the value of delta x is 1, so y intercept is just the value of m. Okay. So here the value of k, you can always understand that we are trying to find out the next value of y. So some value is added in the last y value, and in this way we are trying to find yk plus 1, next y. Now this was the story of the case 1 when the value of this m was less than or equal to 1. Now suppose if we have case 2, in this case if m is greater than 1, okay, then what will happen? We will change the role. Okay, what we will do, we will keep delta y as 1 and calculate the value of x. How? xk plus 1 will be xk plus something. What was the formula for delta x? Delta x was delta y upon m. Okay. Since delta y is given as 1, so what is this value? 1 upon m, right? So here you will add 1 upon m. So this is the thing. Now this was the assumption, means very easily. Now what you have done is you have just calculated m and considered what is the slope. If the slope is positive, these are the two cases. If the slope will be negative, there will be other two cases. I will show you. If the slope is positive, then there are two cases. Either the value is less than equal to 1 or slope is more than 1. If it is less than 1, then the best thing is you will keep x as unit 1 pixel and find out what will be the value of y. Definitely m will give you certain value. It might be since it is less than 1, you already understand. So either it will be more than 0.5 or less than 0.5. Whatever value is coming, you will add it to this, and certainly you will get some fraction thing, right? That fraction you will round it towards the nearest integer. If at all it is less than 0.5, if the current value of yk plus 1 is less than 0.5, you will take it to the floor. If it is 0.5 or more, you will take it to the ceiling. That is the thing. Similarly, in this case, if you will keep the y-intercept as unit 1 and xk plus 1 as xk plus 1 by m, you will get certain value and round it off. Let me show you the other case also, where you will keep this thing. If you are having this as negative, so slope was positive, now the slope is negative. Slope is negative. That means the value of m is less than 0. Okay. So which means the line is going in this direction. In that case, what you will do? No problem. So always you have to keep in mind that you are drawing the line from left to right. So this is x1 y1 and this is x2 y2. That's why the slope is negative. Since the slope is negative, in this case what you are going to do is you will have to do this thing. You will have to increment x and decrement y, right? So you will keep delta y is equal to -1 and you will find x. So xk plus 1 will be xk minus 1 by m. no. We will have to consider these few things, that when the line is like this or that, hello? Okay. Anyway, these two things here we are considering. The first thing was slope was positive. Now the slope is negative. So these are the few things that we have to consider here. So if the slope is negative, let me come from beginning again, that the slope was positive. These are the few cases. It is less than 1 or it is more than 1. We did this thing. The same thing here we are doing. This equation actually minus here and minus here also. Here is minus whenever we are coming from right to left. If we are reading from right to left, if we are drawing our line from right to left, in that case we will have to decrement, right? So we are decrementing the y also, minus 1, and the x also. If it is the case that we are just having the negative slope but we are moving left to right, in that case you can see we can move the x value, right? In that case you will have delta x is equal to 1, and the y-intercept yk plus 1 will be yk minus m, isn't it? Y will keep on decreasing and x will keep on increasing. So keeping these few things in mind, that slope is positive or negative. If the slope is positive, the line is like this. Now here you have to read from left to right, means plot from left to right or right to left. If you have to plot from left to right for the positive slope, then you should keep all the things positive. If you want to plot from right to left, then you should keep both the things as negative. And just you have to reverse this thing for the negative slope. Okay, if the negative slope is there and you want to print left to right, in that case what you have to do, you will also consider this thing, the value, whether it is m is less than 1 or greater than 1. Accordingly you will choose x or y intercept. So if it is less than 1, you will keep it as 1 and choose y with minus sign. You will, in this case, you will choose y as 1 and keep finding x with minus sign. So accordingly here you have to judge one thing, that it is x1 y1 and x2 y2. What is the slope? Slope, either it is positive or it is negative. Now either you have to draw from left to right or right to left. Accordingly you have to match the values of positive and negative here. That is the very simple thing that you have to do for DDA line drawing algorithm. So this DDA algorithm, you can see it is very simple and fast enough. However, there is one more algorithm, we call it as Bresenham's line drawing algorithm. We will see it in the next video. Thank you.